In this tutorial, we are going to talk about the unit circle. So before we specifically talk about the unit circle, let's talk about circles in general. So the first thing we need to remember from our geometry class is what the equation of a circle is on the coordinate plane. So I found this just to show you a quick reminder of what the equation is. But if you have a circle somewhere on the coordinate plane where the center of the circle has the coordinates hk, and the radius of the circle is r, and then the point xy could be any point somewhere on the circle, xy, then you can get this equation here. So x minus h squared plus y minus k squared equals r squared. So for instance, you could have something like x minus 2 squared plus y plus 3 squared equals 16. And what this would be is you would have a circle where the center is 2, -3, right? Because it's minus h and minus k, where hk is the center. So minus 2 means 2 is the x coordinate. And this is the same thing as minus -3 to add 3. So -3 would be the y coordinate of your center. And then over here, r squared is what it's set equal to, which means in this case, 16 is r squared, and therefore r is 4. So you would have a radius of 4. So you would have a circle where the center was at 2, -3, right? So 1, 2, and then -1, 2, 3. Here's your center, but then your radius is 4 units. So 1, 2, 3, 4 units, 1, 2, 3, 4 units. So it's going to be something like this all the way around. So let's write that out. So again, the equation is x minus h squared plus y minus k squared equals r squared. And that's where hk is the center of your circle and r is the radius. So we can use this while we're trying to figure out more about the unit circle. So the unit circle is a circle of radius 1, and it's actually centered at the origin. So we want to know, what is the standard equation of the unit circle centered at the origin? Well, if it's centered at the origin has the coordinates 0, 0. So h is 0 and k is 0. And the circle has a radius of 1, which means r equals 1, and therefore r squared is also 1. So here we would have x minus h, or 0, squared, plus y minus k, which was 0, squared, equals 1 squared. So if I'm going to simplify this, x minus 0 is still just x. So x squared plus y minus 0 is still y, or y squared, equals 1 squared is 1. So x squared plus y squared equals 1 is the equation of the unit circle. This is going to be something we use a lot this semester, so it's going to be important that you remember that. So let's talk about the types of questions I could ask you regarding the unit circle. So the first question says, show that the point radical 3 over 3, comma, radical 6 over 3 is on the unit circle. So we basically want to prove that this point that has the coordinates x, y is somewhere on the unit circle. So it's somewhere along the circle, which was centered at 0, 0 and has a radius of 1. So the unit circle is actually, whoops, if I could draw a little bit better, this circle here, right? It has a radius of 1 and it's centered at the origin. So I want to prove that this point is on that circle. So the way that we can do that is by remembering, well, the equation for the unit circle is x squared plus y squared equals 1. So I need to show that if I plug this value in, root 3 over 3 for x, and root 6 over 3 for y, this equation is a true statement. So we want to take root 3 over 3 and square it, and add that to root 6 over 3 squared, and confirm that we do get 1. So it's all about work here. You're showing that this point is on the circle. So you don't want to skimp out on your steps for the work that you're showing. So remember, squaring something is just multiplying it by itself. So multiplication comes before addition. So I'm going to multiply root 3 over 3 times root 3 over 3. Root 3 times root 3 is 3. And 3 times 3 is 9. So we have 3 ninths, plus root 6 times root 6 is 6. 3 times 3 is 9. So 3 ninths plus 6 ninths does equal 9 ninths, which does equal 1. So it is making the equation true. So we can show that this is actually on the unit circle. What happens if I give you a point and I tell you, hey, this point is on the unit circle, and I'm telling you that it's in quadrant 4? I need to know, what is the y coordinate. Well, the point of me telling you that it's in quadrant 4 is because think about, with the unit circle, let's say if this is your unit circle, there's 2 locations where you would have an x coordinate of 2/5. So let's say if this point has an x coordinate of 2/5, comma, y, but doesn't this point also have the same x coordinate? So we need to figure out this point because they're telling us it's in quadrant 4. So knowing it's in quadrant 4, remember this is quadrant 1, 2, 3, and 4. This is telling us essentially that your y has to be negative. So we need to keep that in mind when we're solving for it, that we're not looking at this point where y is positive in the first quadrant, we're looking for this point down here. So again, our equation plays a role. X squared plus y squared equals 1. I know 2/5, but I'm solving for y. So let's plug in 2/5 and let's solve. Well, 2/5 squared is 2/5 times 2/5. So 2 times 2 is 4. 5 times 5 is 25. So 4 over 25 plus y squared equals 1. Taking away 4 25ths from 1, or in other words, 25 25ths minus 4 25ths would be 21 25ths. So y squared equals 21 25ths, and therefore we need to solve for y by square rooting each side. But remember, even though typically here we would say you could get positive or negative, our answer should be the negative version. So we would say that y equals the negative root 21 over 25, which we don't want to leave it like this. We don't want to leave a fraction in the radicand. So we would instead say this is negative root 21 over root 25, because we are able to say that the root of 25 is 5. So negative root 21 over 5 would be our y coordinate.